Good day, everyone. We are Group 6, and today we'll be discussing a very important device that plays a crucial role in protecting electrical systems, the lightning arrestor. In our presentation, we'll cover the definition and purpose of a lighting arrestor, the possible damages caused by traveling waves, how a lighting arrestor works, and its importance in electrical protection systems. So let's get started and understand how this small device acts as a silent guardian of our electrical networks. What is a lightning arrestor? By definition, a lightning arrestor, also known as a surge diverter, is a protective device used in electrical substation. Its main job, to shield equipment from traveling waves caused by lightning or switching surges. In simpler terms, it diverts abnormally high voltages safely to the ground, keeping the power supply running smoothly and preventing equipment damage. It's usually connected between the line and the earth in parallel with the equipment that needs protection. Also here are the damages caused by traveling waves. Now, what happens if there's no lightning arrestor? These traveling waves can cause serious damage such as flashover inside transformer windings, ruining their insulation. External flashover between transformer terminals. It's like a mini lightning bolt jumping across components. And even damage to insulators due to extremely high voltage peaks. In short, one lightning surge can cause thousands or even millions in equipment loss. Here's the working principle of a lightning arrestor. So how does a lightning arrestor work? When a traveling wave or surge reaches the arrestor, it sparks over once the voltage exceeds a preset level. This creates a low impedance path for the high voltage surge, allowing it to flow harmlessly to the ground. Because the surge impedance of the line limits the current, only the surge energy is discharged, protecting the system from damage. And here's the smart part. The lightning arrestor only conducts when a surge occurs, not before and not after. Under normal conditions, it stays inactive, allowing regular current to pass through the system uninterrupted. The shape of the voltage and current across the arrestor ensures that the connected equipment remains safe even during high-energy lightning events. So the next time you see a lightning flash across the sky, remember, deep inside every substation, a lightning arrestor is standing guard, silently protecting our power system from nature's fury. And it's not just a piece of equipment, it's the unsung hero of electrical safety.
So good day everyone. I'll be explaining the ideal characteristics of a lightning arrestor, which you can see in the summarized in this slide. So let us now begin by understanding the graph on the left. So it shows that the relationship between current and time during a lightning surge. So when a surge occurs, the current suddenly increases to a maximum point. So it is labeled as Imax, and then gradually decreases as the surge energy is dissipated through the arrestor. So now let's go through the four main characteristics one by one. Okay. Number one, no current during normal conditions. So an ideal lightning arrestor should not conduct any current when the system is operating normally. And the second one, quick response to the abnormal voltage. So if there's a sudden high voltage or transient surge, the arrestor should immediately break down and provide path for the excess current to safely flow to the ground. So number three, ability to carry discharge and current safety. So once the arrestor conducts, it must be strong enough to handle the surge current without being damaged. And number four, fast recovery after the surge. So after the surge is over, the arrestor should stop conducting right away. So in summary, an ideal lightning arrestor should remain inactive during normal operation. Yeah. So as you can see in the picture, a lightning arrestor is always placed close to the equipment that needs protection. So the reason for this is simple. So the closer it is, the faster it can divert dangerous surge voltages away from the equipment. It is minimizing possible damage. In an AC system, an arrestor are usually connected between the phase and the ground. So this set up provides the safe path for the surge to flow directly to the ground. While for the DC system, the connection is between a pole and the ground. So in an extra high voltage AC systems, these surge diverters are used to protect major components such as generators, transformers, bus bars, transmissions lines, and of course circuit breakers. So meanwhile, an HVDC system, lightning arrestors are placed to protect buses, converter units, valves, reactors, and filters. So let us now talk about the lightning arrestor types and working. So as you can see, a lightning arrestor is used to protect the power systems from the high voltage surges, such as those caused by lightning or sudden charges in voltage. Its main function is to discharge an excessive voltage safely to the ground before it can damage the equipment and then restore the system to the normal operation afterward. So to perform this protective function properly, a lightning arrestor must have the following characteristics. So first, it should not allow any current to flow to the ground as long as the system voltage is normal. And second, when the voltage rises above the certain predetermined level, the arrestor should quickly provide a path to the ground, allowing the surge energy to dissipate safely. And the third one, once the voltage returns to normal, it should immediately stop to the current and restore the insulating properties between the conductor and the ground. And lastly, the arrestor must not be damaged by discharge or should not be capable of repeating process automatically whenever needed. So, in summary, the lightning arrestor acts like a protector of electrical system, staying inactive during normal operation, but reacting instantly to any voltage or lightning surge to keep the equipment safe.
So, what's the working principle of lightning arrestor? With a voltage surge traveling on the conductor reaches the point at which a lightning arrestor is installed, it breaks down the insulation of the arrestor momentarily, allowing the voltage surge to discharge to ground. As soon as the system voltage drops below the predetermined value, insulation between the conductor and ground is restored and further current flow to ground stops. The principal lightning arrestor types are as under. The first one is the rod gap arrestor, second is the expulsion type lightning arrestor, and lastly is the bulb type lightning arrestor. So what is a rod gap lightning arrestor? It is the simplest type of lightning arrestor. It consists of two rod electrodes, one of which is connected to the line and other to earth. The rods may be in the form of horns also. Under normal operating conditions, the gap remains non-conducting when a high voltage surge occurs. The gap sparks over and surge current is drained to earth. Such arrestors suffer from the following disadvantages. The first is the operation is affected by climatic conditions. Second is after the surge is over, due to ionization of air, the area in the gap is maintained even at the normal supply voltage. And lastly, increased possibility of bird faults. Due to the above disadvantages, the rod gap arrestors are used only as backup protection with the main arrestors. So makita mo sa diagram na to is diagram ng isang rod gap line arrestor. Wherein yung isang rod is nakakonect sa line, then magkakaroon tayo ng rod gap, then lastly is meron tayong rod na connect sa earth.
So, welcome to this concise overview of lightning arrestors, essential devices in power systems designed to protect equipment from the damaging effects of lightning strikes and other voltage surges. We will explore two primary types, the expulsion type and the bulb type. The expulsion type and the bulb type. So, let's begin with the expulsion type lightning arrestor. So dito, it consists of an arc extinguishing chamber in series with an air gap. The area extinguishing chamber is in the form of fiber tube which interrupts and after discharging the surge by the generation of gases. So when a voltage surge occurs that is sufficient to spark over the series gap and the gap in the fiber tube, It discharges the current flows to ground. The arc in the tube attacks some of the fiber of tube walls, releasing a large amount of a relatively cool and non-conducting gas. So the gas produced in the fiber tube acts not only to extinguish the area, but also builds up high pressure and expelled through the lower electrode, which is hollow. So as the gas leaves the tube violently, it wipes out the ionized air around the area. Due to this strong deionization effect, the area goes out at current zero instant and will not be re-established. So ang expulsion type lightning arrestor has a current rating in addition to the voltage rating. The maximum current rating must be equal to the short circuit current available at the point of installation. So these are generally used on towers for the protection of transmission lines. So yun yung expulsion type, yun yung ginagawa niya kapag may surge, so may mga voltage surge. So sa next part, so we now transition to the valve type lightning arrestor, a more sophisticated design widely used for protecting high voltage apparatus. So ito yung mas gamit, tsaka mas maganda daw. So valve type lightning arrestor consists of an outer ceramic body containing a set of resistances or valves and spark gaps in series. The resistances are made of a special silicon carbide ceramic o yung mga metal oxide. So it possesses the characteristic of being substantially an insulator at one voltage and then changing to an excellent conductor at a higher voltage. The transition is due to the voltage changes only, not to heat as in other valve materials. In high voltage surges, the spark across the air gap and discharge current flows through the valve to the ground. So since the valve has a low resistance under high voltage and a high resistance at a normal voltage, so as soon as system voltage becomes normal current flow, it stops. These are this anomaly gets extinguished and the arrestor regains its original state. So the valve type arrestors are extensively used for protection of generating stations, substations, overhead lines, cables, and rotating machinery. So gamit siya mostly sa mga station, sa lahat. Sa mga data nakikita natin, gamit siya. So they are rated for voltage only and are designated as 70%, 80, and 100% arrestors. The 80% arrestors are suitable for solidly grounded systems, whereas 100% arrestors are used on systems with isolated neutrals or those earth through impedances. So, ayun, to sum up, yung dalawang tong arrestor na to, sila yung taga-protect ng mga equipments. Yung mga voltage surge kasi parang kidlat. Kidlat. Tapos, i-divert nila yung kidlat na yun sa ground para hindi tamaan yung equipments. Para hindi masira yung equipments. Kaya nagawa tong arrestor nito. Kaya gamit na gamit siya sa mga lines and power stations. Sa mga transmission lines. Ayun.
Now let's move on to the next slide, which shows the construction and equivalent circuit of a bulb-type lighting arrestor. As you can see in the diagram on the left, the arrestor consists of three main parts. A porcelain housing, which provides insulation and protection for the internal components, a series of spark gaps, and a set of non-linear resistors. At the top, we have the current terminal, which connects to the line, and at the bottom is the ground terminal. The spark gaps act as a switch. Under a normal condition, they provide insulation and prevent current from flowing. However, during a lighting surge, The voltage rises and the spark gaps break down, allowing the surge current to pass through the nonlinear resistors to the ground. This nonlinear resistor, usually made of silicon carbide or zinc oxide, limit the voltage across the equipment by allowing more current to flow as the voltage increases. This is what keeps the system safe. On the right side, we have the equivalent circuit. It represents the combination of spark gaps and nonlinear resistors connected between the line and the ground. This model helps us understand how a arrestor conducts only during overvoltage condition. Next slide. We can see how the bulb type arrestors are classified. They are divided into four main types based on their application and voltage level. First type is the secondary type arrestors. These arrestors are used with medium voltage apparatus, typically in farms or areas prone to lightning. The second type is the distribution type arrestors. It is commonly used on distribution lines and substations up to 22 kilovolts. The third type is the line type arrestors. It is suitable for voltage up to 66 kilovolts and sometimes even higher. And the fourth type is the station type arrestors. These provide the highest level of protections and are used in substations or power stations where equipment cost and service continuity are critical. It is also important to note that performance of any arrestors depends on a good connection to the ground. Without proper grounding, the arrestors will not function effectively. Lastly, the arrestor should always place as close as possible to the equipment it is meant to protect. And the ground connection should be kept short and direct to minimize resistance and improve efficiency.
And that concludes our presentation. Thank you for listening.